There was supposed to be a ball game here today. There's no one in the bleachers. Let me go ask this person over here. Take me out to the ball game. Take me out to the park. Hey, is that you, Dr. Romano? I was supposed to watch a ball game today. Dr. Romano, I was supposed to watch a ball game today. What are you doing out here? I want to play some ball, Dr. Romano.
You want to play some ball?
Yeah.
Let's play some ball. Let's play some hard ball. Come over here.
What?
I'll show you some ball.
You're doing work out here
No.
too?
What I want to do is I want to show you what's known as an organic chemistry mechanism. In this mechanism, what you want to do is to focus on what we call the arrow movements. Don't worry about the reaction. But what we're going to do is we're going to take a nitrile and convert it into what we call a thionoester. Don't worry about the names, but focus on the chemistry. As a good general rule, if you can't name the step, you're probably making an error. So let's take a look.
Okay.
In this first reaction, I am going to take benzyl nitrile and I'm going to treat it with a thiol and H plus catalytic. That just means we're adding a catalytic amount of acid. And as you can see, what I first done is I did a protonation step where I protonated the nitrile. That's easy enough. In the next step, I use the thiol as a nucleophile. Notice how the arrows move from the sulfur atom onto the carbon and the bond moves out. So that's a nucleophilic attack, and I get this intermediate here. Now, the H that we used comes off, and we're left with the solvent. So the solvent has free electrons, and that can be used to deprotonate our sulfur compound. And as you can see, we now have this intermediate formed. So yay means I'm at the halfway mark. Now let's keep going. We have more acid. Notice we're going to protonate the nitrogen. That's a protonation step. Then the H2S, hydrogen sulfide, acts as a nucleophile again. Notice the arrow movements. That's all I want you to understand is how the arrows move. We do a nucleophilic attack. Electrons move out. Then again, this is a deprotonation step. Pull off the H. This moves in. Now we're going to set up a leaving group. We protonate the nitrogen leaves, bond forms down, and then as you can see, there's the ammonia, there's our leaving group. And then the last step, the solvent removes the H, and we are left with the thionoester. This is a hard problem, but what I care about you focusing on is to understand the way the electrons move. We're not going to ask you to do a synthesis of something like this. This is too hard. But the arrow movements are very easy. All I've done was basically protonate, attack, deprotonate, etc., and set up a leaving group. All right, I hope this helps. If you can understand this, you'll be in good shape for the DAT exam. All right.
Hey, Dr. Romano, I have a question. I like your T-shirt from Miami. Did you go to that school?
I did. I was a graduate at the University of Miami and New York University. All
okay,
right,
Dr. Romano. I'm glad I got to play a little hardball with you. Good day to you, sir.